Hello everyone. Welcome to the final submodule of a brainwave acquisition and recording system demonstration. So in this module, mainly we will talk about how MATLAB can be useful for EEG signal analysis or EEG signal processing. So initially, I will tell you I'll give you an introduction about a toolbox named EEGLAB, how it is being useful, and what are the functions which you can do for different recorded EEG files. Then we will see that this EEG file is recorded in different formats across different systems. So we will see a couple of examples of how different files can be imported or loaded in MATLAB using scripting and as well as using a GUI of EEGLAB. So let's talk about EEGLAB a bit before I will demonstrate some of the very basic things about EEGLAB. So EEGLAB is prerequisite for any kind of EEG and ERP processing using MATLAB. There are some packages and functions which have been already made, so you can directly use that function and you can do your analysis. Otherwise, it will take a lot of time again to generate the same functions. Yes, always you can make use of different combinations of function and create a plugin for specific applications, but all the functions, documented functions or the included function in EEGLAB makes EEG signal processing very simpler. So you can have a look. In fact, I'll show you when I will demonstrate EEGLAB basic functions and plugins and all the things I'll try to include. So it supports both. Like in PsychoPy, we have seen that we were generated stimuli using GUI, because at that time it was like you have to generate a stimuli mostly once for experiment or twice. But whereas in this case, when you record across multiple subjects, instead of GUI, a scripting is advisable, because you don't have to repeat the same procedure again and again. You can automate the stuff using scripting. So it supports both. Basically, how you can generate a particular script for a GUI operation which you have made, and one particular scenario, whether GUI is better or scripting. All this thing I will try to cover. Further, we will see that scripting, as I mentioned, it's advisable. One last important thing is plugins. So in the demonstration, I will show you that there are many plugins which are already available with thousands of downloads and various applications. Many of them are still in progress and getting updated with more and more features. So first we'll see the demonstration or introduction to EEGLAB. I have included from scratch, so how from downloading EEGLAB to what are the basic things you can do with a sample data set. All this thing I have tried to cover. So let's see first and let's see how EEGLAB works, or basic introduction of EEGLAB. So let's quickly see how to download EEGLAB. You can search it and it will redirect to Schwarz Center for Computational Neuroscience site. Here you can add your basic details, your email ID, your name and your area of research, and submit it. You should be able to download the latest version of EEGLAB. So once you download EEGLAB, it should look like this. This is the latest 2020 version of EEGLAB. It consists of functions, obviously, which you are going to use for signal processing. There are various plugins, sample data, and sample location files which you are going to use. So if I open this function folder, these are the mostly used function for signal processing analysis. Most of them are used for scripting. All the pop functions are used for scripting, and further This is for GUI. There are signal processing functions, statistical functions, and all the different functions available. This is very important thing that you see the different plugins here. So clean row data is basically a plugin to process or clear your row EEG signals. ERPLab generally is for event related potential extraction to create different beans for particular events and all. So Neuroscan is required to import some file which has been recorded in a tool called Neuroscan. So all these different plugins and all are there. One interesting thing I would like to recommend all of you is that you can go through the list of plugins for MATLAB. Very important, all these plugins, if you install and if you can study, it will make life easier for EEG signal processing. So I would request all of you to at least take a look at the plugins which is useful for their analysis or their application. So coming back to EEGLAB, finally, EEGLAB is a toolbox which has been used specifically for EEG processing in MATLAB. So I have already added this into my paths folder. So I will add this thing into path and see if I can run the EEGLAB. So once your downloaded EEGLAB package is in path, you have to write a command EEGLAB. It should open EEGLAB. Let's wait. In EEGLAB, you can process it in two manners. One is using the scripting, like typing a command and get the desired work done, whereas in other way it is using GUI. So I will show you both the ways. In this newer version, as I have downloaded ERPLab, it is showing ERPLab, ERP sets, everything. But generally it should start with, so acquisition of your input data files generated from particular system should start with file menu. Let's import some of the data. Before importing, I'd like to tell, I was telling two things. One is GUI, one is scripting. So we'll start with GUI. We'll go to scripting. We'll see how there is a way from GUI to scripting and some tricks. So first, let me import one of the sample data set which I have. Let's import EDF file. So I'll go to this from EDF file. This is a sample EDF file here. So I will give this file as an input. It will ask me a few questions, like if I want to see all the channels, if I want to see the entire data recorded throughout the complete data stream and all. I will for now keep simply put I would like to go ahead with default parameters. I am not going to change anything. One thing to notice here is the function name is written. Like in GUI, whatever function you are executing is scope biosig. Based on my values here, a function with proper attributes and key value pair will be used. So for now I'll just simply say OK. Further it will process and it will ask me the name of the file. I can let's keep it as it is, EDF file. So that will be the name of my new data set. Here if you can see the data set menu, so this data set will appear there, or I'll just simply write EDF file 1 and I will say OK. So this has kind of imported the data on .edf file. EDF is European data format. .edf file into a MATLAB. Further, if I want to see the data, I can go to plot and scroll data. So I am able to see the data. If you can see it properly, all this y-axis is different channels, And in experimentation module, I told you about different kind of montages. So if you notice it clearly, that fp1 minus f3, f3 minus c3, c3 minus p3, p3 minus o1. So this, all this bipolar bipolar channel representation is nothing but your double banana montage. Now this is your data. Very difficult to generate an interpretation. We can increase or decrease your amplitude scale using this function. Let's increase it, so in a way we can see some channel wise movement. Okay, so now you can see mainly the activities which is being happening here. And like we can notice that it is prominent in f4 and f3. So something related to frontal lobe, maybe some movement also. But let's say before we analyze it further, I will tell you a few basic things. Using this, you can select a particular time range you want to see per one display. Now I have changed it to 10. Also you can change the number of channels what you want to display. In one display currently 18 channels is there. If I change it to 5, then I can only see those 5 images. So based on your analysis, based on your criticality of problem, you can analyze the number of channels, and you can accordingly adjust the time axis. You can move in the time axis using this push button. This will second by second you move. If you use this button, it will shift the entire time interval. Currently it's 5 to 15, so it will shift to 15 to 25, it will shift to 25 to 35, and so on. So now if I talk about, let's say I'll first shift it to original number of channels. Now I will check. I want to, let's say this portion is artifact. Okay, we will go to initial time. Let's say this 5, in between 4 to 5 there is an artifact. So what I will do is I will select this particular region and I will simply reject it. So it will again ask that earlier EDF dataset was 1. Now I am going to change it as EDF dataset 2. Once I do that, now I have a 2 dataset here. So I can process any of the dataset by checking the data. Let's plot it together. Let's plot it again like we plotted it before. It was for 10 seconds. So I will again change this time range to display. And if you can remember, the time amplitude scale was around 5000. Let's keep it 5000. So in between there was some movement between 4 to 5. Here you can clearly see a boundary which gives an indication that some of the channel has been removed. Okay, so this is kind of basic things which you can do. So these are the basic operations using EEGLAB. One more important thing about EEGLAB is that whatever processing you have done on your EEGLAB GUI, you can recall it using EEG.history. EEG.history. Come on. So from the beginning, whatever you have done in this session, you can see it here. Open the EEGLAB, imported the file, name that set file as EDF file 1, then you plotted it, again you name other file as EEG file 2, in which you have rejected some of the events, some of the indices data. So this is how you will come to know for one particular GUI operation which kind of scripting function should be used. Now GUI looks very easy to use and user friendly. Then why we are going for scripting? We have seen using PsychoPy GUI we can generate a multiple stimuli, various stimuli, and it is very easy instead of writing a Python script for that, which was complex. So why should we emphasize on more on scripting? So the clear reason behind that is stimuli generation is mainly once for one done once for an experiment, whereas this is signal processing. So it should be done for multiple subject very easily. So every time you will not be there to perform GUI operation and see the final data. It will be time consuming. So to avoid that, for batch file processing or multiple subject signal processing for EEG, what we use is basically a scripting. Now I wrote here EEG.history. It is nothing but it is stored in the structure EEG. So if you successfully import your file, you will be getting all these fields under EEG structure, which is the most important for further signal processing. It has all the channel locations where it has been placed, whereas it has the data as well, the values, most important thing for all channels. If you can see that it's recorded for 3 lakh, almost 3.5 lakh samples at 125 rate, 125 sampling rate. So if you want to know exactly how many minutes the recording has been done, you can use this data of number of samples and sampling rate. You should be able to find out that this is for which how many number of what is the duration of the recording. So yeah, these are some of the basics of EEGLAB. I hope all of you have understood this thing. Similar way, for different acquisition systems, we have different formats of final acquired data set, and how we can obtain it using different scripting options that we will see in upcoming videos. So for now, I hope all of you have understood the basic introduction of EEGLAB. We'll shift our focus to data acquisition using EEGLAB for various formats from different EEG acquisition system. So all of you have seen a demonstration of EEGLAB. So now most of you have some ideas about which kind of software EEGLAB is and how you can convert your GUI operation into scripting using EEG.history function or EEG.history variable, because EEG is a data structure. We will see in the upcoming data acquisition videos demonstration. We'll see that it's basically a structure in which history is one of the field which stores whatever operation which you do, equivalent command. So yeah, different system stores your EEG information into different formats. OpenBCI ports stores in .txt file, the simplest form you know, and you can see it in Notepad. Neuroscan stores it into .cnt file, whereas Nicola EEG viewer mostly used for long run EEGs, and when many number of electrodes are placed, let's say for epilepsy, and many number of electrodes are placed on your skull. So in such cases, that's EDF files. EDF is the standardized European data format for EEG recording. So I have included one sample data of each type, one TXT file, one CNT, and one EDF file, and I have shown how you can acquire the data, basically biopotentials and event, using MATLAB. So and also I have shown how you can see the events or triggers, like auditory stimuli, visual stimuli, what are stimuli you generated, that digital pins, how you will fetch it from the acquired loaded EEG data. So next would be 3 demonstration, quick short videos. So in case in future any of you would come across such recorded files, you will be able to fetch the data by your own. So next would be this 3 demonstration videos of acquiring EEG and events from recorded files, and that will conclude this submodule, and as well as this 4-part lecture series on brainwave recording, acquiring, and processing. We have only seen loading the brainwaves into MATLAB. Further, if time permits, we will see how you can process it. Like pre-processing is also important step. Further, extracting a particular biopotential, any time locked event. So all this thing, epochs and all, like if time permits, we'll cover these topics as well. But for now, flow wise, let's see how acquisition happens and how different formats can be loaded into MATLAB. I will see you in some other module. You can enjoy this 3 different demonstration, and then we'll meet in some other module for some other topic. So in this short module, we will see how to import your recorded files into MATLAB for further processing. So we have a file here. In this module, we will see a file which is generated through OpenBCI boards. How to generate OpenBCI Cytone or OpenBCI ganglion recorded files from text file to your MATLAB workspace. So this is the sample file. I will show it to you first. So if you open any of the OpenBCI recorded file, it looks like this. This is the raw data recorded for 8 channels, and it is recorded at 250 Hertz. Data wise, it is an array. From here, it's an array of 16 columns. This column number 2, 3, and 4 are recorded channels. Rest 5 we have not used in the particular experimentation. Here there are 3 channels which has been used, as well as further this 5 zeros and 1 are nothing but your digital input outputs. So we have inserted our trigger in pin number 11. So while extracting events, I will consider, or I will take the value of pin number 11. I'll show it to you. If you can see here the 11th column is constantly getting toggled between 0 and 1. We will observe the same in MATLAB as well once we successfully import the file. So let's see how we can generate this file. How we can also, we will see how to write a script in case of multiple subjects. Scripting is advisable. So how we can write the script in order to make life simpler. So in order to import this text file, there is a function in MATLAB which you can use. I will name this variable, or whatever ones get imported, as sample txt. Okay, and let's load the file. So while you load the particular file, you should write everything like the path and the file name. Now instead of writing path and file name, I will use a trick here. If I press pwd, it shows me present working directory, currently in which folder I am while running it into MATLAB. So what I will do, I will use a string cat function using this pwd as a one of the string. If you can see here, what I will do is I will use string concatenation function, so it will merge all the inputs. After this, I'll put backslash once, and then I will write the file name, which is sample txt.txt. Now this also should be given as a string, so it should be something like this. So ultimately it will merge all the things, and it will load my text file into sample text variable. So let's see. So if you can see here, sample text variable has been created and saved. The same thing what we have seen in the notepad you can observe here, as well as if I go to the 11th column, and once I go further down, I should be able to see the change in triggers. I hope you can see here. If I scroll it slowly, you should be able to see zeros are there in the 11th column, again 1 for some period of time. So this is how you can analyze the trigger, which is the trigger. Though it's same in both 11 and 12th column here, you can take any of the column as an event trigger. So now how can we take a data out of this? As I already mentioned, this particular experiment is for 3 channels. So column wise, it is column number 2 to column number 4. I'll show it to you one more time. It's column number 2, column number 3, column number 4. So these are my biopotential values right now. So what I can do is, and make sure it's a row value. You might say that it is in the 10 to the power 3 or 10 to the power 4, but yeah, it's a row value which is generated by addition of so many noise that we have to remove gradually using proper pre-processing algorithm. So what we can do here is, I will store it into a variable biopotential. The first 3 potential I will save it as a biopotential. Now I can take it from sample text and I will fetch first 3 like second, third and fourth column. So this is basic MATLAB way to extract particular columns from any array. Very simple. So that 3 channels has been recorded here. You can check this thing here. Furthermore, let's take a channel also, event data, or channel should we say event channel. So we can store in the similar fashion from sample.txt, and I need now 11th column because we have already seen that 11th column digital input output keep getting toggled. So now we have both the data, event channel as well as our biopotential. So let's see just for visualization how it looks like. Plot biopotential. For now we will plot only one channel just to give you guys an idea. So it is something looks like this. So the first channel was having some starting value around 8,000 and all. So it is looking like this. One more thing to note down here is, if you go to the sample text file, it is showing that it is sampled at 250 Hz. So whatever number of samples are recorded, it is recorded as 250 Hz. Currently this 17409 is the number of samples which you have, and it is recorded at 250 Hz. So it will give you an idea that this recording is performed for duration 69 seconds. Now if you want to visualize that how it has been recorded for 69 seconds, you can again plot it with respect to time axis. In this case, what you can do is, you can take an additional variable which is considered from the same length, which is of the same length of biopotential, and you can divide it by 250. It should give you the original time scale in seconds. Let's write that. Okay, so let's see. So this is nothing but I already mentioned it's around 16-70 second video, so you can get it with respect to time. Now you can analyze that and you can check it further. Okay, let's see the triggers as well. So we can plot now event channel. I already mentioned that event channel is your digital input, so it will be 0 and 1. In order to just make it look fancy and good, I will just put a y limit to 0 to 1.1. Let's say that x, and again I will plot it with respect to a generated time. So I will follow the same thing which we have done it in the case of biopotential, I will give it indices, time indices of the same. You can use length of biopotential as well, that's fine, as long as you can plot the channel properly, that's completely okay. And I have to okay, divide by sampling rate as well. So I guess now we should be able to see the triggers as well. That's it. So these are the triggers in a similar fashion you are getting from your one thing to note down here is that experiment has started, and after few seconds the triggers have been inserted. So you can further analyze it. You should consider the data corresponds to only the time when triggers have been given. If your experiment is audit, like some evoked potential generated using this trigger, you can further check it, zoom it to verify whether the generated data is really accurate or not. So I have shown you an image while explaining auditory stimuli. This is the output of the similar auditory stimuli, in which you can clearly see that it is getting repeated twice in a second. So 2 Hz auditory stimuli and the similar kind of stimuli has been presented here. So I think this is a realization of what I showed that we have made using PsychoPy. So similarly, you can try out your own triggers and record your potentials with some of the biopotential acquisition device. In our case, we have used OpenBCI Cytron board, which I showed you in the previous module. So I hope this MATLAB acquisition of your data and events is clear, and you can now import the data and further process it. Let's see how we can load different EEG file formats recording from various devices. We have already seen one instance of that. In one of the videos I have shown you how we can import OpenBCI Cytron board recorded file, which was the sample txt.txt file, how you can record, how you can rather import that file into MATLAB for further processing. In a similar fashion, we'll see we have 2 more instances. One is sample cnt.cnt file, which is the file recorded from our Neuroscan EEG system. So how you can load the particular file. In OpenBCI case, there was a text function, a load function for the text file. In this case, we have a specific function which is poploadcnt. This is a function of a Neuroscan plugin. It's also a part of EEGLAB function. So make sure that your path you have added EEGLAB into your path, and path is added. It's already added in this case. So now, and one more thing, let's see what will be there in your poploadcnt function. I'll just open the help of the function. It will tell you what are the inputs required for the function, what is the different ways or different usage which you can give. At the same time, you can know what are the optional input and output. Very important thing here to note is output is EEG data structure. Earlier we have seen we saved up values generated from text file as an array of floating number, whereas in this case the final output will be stored in the form of data structure. So let's implement this. Let's see if we can get this data out from the CNT file. We will name the finally generated output structure as EEG. As I mentioned, we are going to use popload CNT function. Here, input to popload CNT function is the file name, but it should include the entire path. So like I have shown you, you can use a string concatenation with file name, as well as you can write the entire path as well. So I will use the same method which I used for OpenBCI data and channel acquisition. This will be my sample CNT file, with extension, and I have to check for brackets as well. Once I check that, I can load this file and we can see where the data lies. So it will store as a EEG data structure. You can go inside this and observe the field. So here, if you can see, the total number of samples are 87,600 and sampling rate is 1000. So 1 second has been recorded in 1000 samples. So every 1 millisecond it records a sample. So in other words, if my samples are 87,600, the data is recorded for almost 87.6 minutes. That's what you can see here, X maximum. Okay, further we will go and check the data, which is one of the most important field for any EEG data structure. So let's see what is there inside. Oh, if you observe the data, it is very evident and clear that first 3 rows has the values which varies with respect to time, and if I just talk about the nature of the values, they are analog in nature, whereas the values in the 4th column, you can observe here it's 0. Further, if I move ahead, still it is 0. So after few seconds it will get toggled. So let's see, let's scroll it slowly. Yeah, here if you see, it has changed to 4096. Now why 4096? Because 4096 is 10 to the power 2 to the power 13 or 14. So a particular bit in the data stream will get toggled from 0 to 1 when a specific stimuli is generated. So other way, it's one particular bit out of bit stream is changed from 0 to 1. So you can see that event is generated, and I just want you people to realize that these three rows are your biopotential, analog in nature. At the same time, this last row is your data, your event data, which has been stored. Now let's quickly visualize what I said. So I'll just clear it here. We can plot one channel from EEG.data. Let's plot second row, and you can see the graph. Again, like you did in OpenBCI, if you want to see this, if you want to see in the time domain, if you are comfortable not in terms of samples, if you want to see it in seconds, what you can do is you can plot the same thing for one column length of EEG.data divide by 1000. This should be why 1000, because we have seen that sampling rate is 1000. Instead, if you want to write, you can write EEG.srate also. That's completely fine. It is just a basic way of addressing a particular variable from your structure. Structure, for all those who are not aware about what is structure, it's a kind of composite data type in which you can store multiple variables. Like if you know variables, there are different type of variables, right? Some of them are integer, float, string and all. Structure is composite data type which can have more than one type of data. Like if this srate is, let's say, double, whereas if I go to the set name is character array. So like that, you can consider structure as a composite data type. And finally, once I am done with this, here it should be dot first. Yeah. So if I run that, it is showing me this kind of graph, exactly in relation or in agreement with what we have seen, that total number of time duration is around 89 seconds, and you can see this kind of EEG movement. Let's quickly have a look at the events. So event was stored in the 4th column. So you'll see the events first. So you need to zoom in to see exactly how this event looks like and what is the time duration between consecutive events. Before that, let's convert the samples into the actual time like we did for biopotential. So in this case, you should use the fourth number of row. Similarly, you can plot it. It should show you now from 0 to 89 seconds. And if I further zoom in, let's take only 4 to 5 iteration. By the way, this one stimulus from here to here interval is your one iteration. You should perform at least 100 or 120 iteration based on your experiment, because this brain response is highly variable, so you need to average out some of the noise, so it will also average out some of the common noise and all. But yeah, if you see here, if you focus on this stimulus onset is at around 6 seconds and it lasts till 6.6 6.5 seconds, so around 600 milliseconds for one period. So yeah, this is how you can analyze it, your events and your biopotential. Further, you can process it based on your requirement. Let's quickly see how we can import the EEG biopotentials and channel from EDF file. So if you have seen the introduction to MATLAB, I have shown you how we can import EDF file using GUI. At that time, I have mentioned that pop bioseq function is used to import EDF file. Now, what is pop bioseq function in EEGLAB? So let's just check the help of EEGLAB. One more thing to mention, that I'm using EEGLAB's function, so you must add EEGLAB to your path. I hope all of you know how to add EEGLAB to a path and basics of your default path and how you can restore it. These are the different ways in which you can implement your pop bioseq function for loading a data from .edf file. These are different optional inputs. You can have a look. So here, let's quickly load the data using pop bioseq function. Output would be obviously like it was there for pop load CNT, would be your EEG structure, data structure. So input should be a string, your file name in the format of string. So I will use string cat function. I will add first input as a present working directory, and finally sample underscore edf.edf. Looks fine. Yeah, check for the brackets and let's run this. So it will store the value in this EEG data structure. So similarly, observe the sampling rate. I think now we are doing this for the second time. You know what are the things to observe. This is the total number of sample. This is the sampling rate. Here you can see the data. It's a bit longer duration, which you can see here. We can see how many sampling points are there and how many, what is the sampling rate. So let's just try to find out the duration. So you can use the same EEG dot points variable divided by EEG dot s rate. This should give you the total duration in seconds. So it's around 2836 seconds. So if I convert it into around, just hang on a second, 2836 divided by 60. So 47 minute recorded data. And one more thing, if you are observed, it was recorded for 18 channels. So it should, like, channels would have covered your entire skull, entire head. Let's see what are there in the channel and where it has been placed using the channel name or channel label. So how you can plot this data? So two ways. First, pop EEG plot. If you don't know what is pop EEG plot, go to the help of pop EEG plot and see the different optional input, require input. So here I see a component. Independent component analysis is a separate signal processing method to show any multivariate data as an addition of independent variables. So you can have a look in detail if you are interested. Further, you can see all these inputs. Generally, we will keep the inputs after EEG data structure as one. So let's plot that. Pop EEG plot EEG. All the other three inputs I'll keep at one. I would encourage you to go to the documentation and check. If you want to change, you can change and play with the sample data set available online. So let's just see how it looks like. Yeah, the similar kind of graph you have seen when I have demonstrated EEGLAB using GUI, and all this is nothing but a double banana which I explained in experimental setup. You can, I hope you remember, otherwise you can play with the y-axis scale using this push button. You can go scroll through the data. If you want, you can change your time axis from here. Let's say I want to see 30 seconds at a time. Play that. You can observe this based on your need. You can spread it, you can stack all the channels, you can spread all the channels, you can normalize all the channels, you can denormalize based on your requirement. This is one way to look at the images, one way to look at the biopotential graphs rather. If you want a specific channels data, you can even use, let's say I need only second, third and fifth channel and in the same pan. What I can do is I can use subplot for 3 plots with data being fetched from second column. It show me for 1 column, similarly for third column, and finally for the 5th column. Here it should be 3, it should be 5. You can even make use all other optional inputs like Y label. Specifically for this case, if I write 5th column or 5th channel, it will appear like that. Like you have seen in the previous case, you have seen your label, right? For double banana montages, I have shown you. In this way, you can see the final data out with this by channel. You can plot it accordingly. You can observe it. You can get the channel location information from here if you want. Which channel or which row corresponds to which channel, you will get an idea. We have plotted 2, 3 and 5, F3, C3 and FP2. The C3, P3 and F4, you are seeing, they are like a reference channel for bipolar double banana montage. So I hope it is clear how you can load your .edf file. One more important thing I would like to tell all of you is that you have seen separately by writing a command window for each file how you can generate your how you can load your values and further process it. But it is advisable for batch processing, you should have a script. So like I said, I have made a script for almost each kind of data inputs. So whatever I am doing, I have just shown you pop biosic function. I will pass this file name as an input and I can further process it. I just only have to give this file name and it should show me the final graph. Just for example, I'll show you this one example here. We're talking about EDF. Here I am already concatenating it with extension EDF, so no need to write EDF. I just have to write it should show me the final plot. So exactly the same plot, whatever you have seen, that has been generated using this function. So similarly, you can make your own script. This is a very simple and small example how you can generate your script. I have generated it in all 3 cases for CNT file as well as TXT file. If I talk little more about that, then if I have a folder where I have a particular set of CNT files, then you can use you can make a provision in MATLAB that you have to give your input directory as an input, and it will search for all the CNT files, and all the CNT file gets loaded in a particular manner. At that time, your output variable should be a function of your number of CNT file. Otherwise, everything gets override in your EEG function. So as and when you see and implement this, you will get more ideas of how you can process the multiple subject and batch files. So this is just a small illustration of how you can load the data recorded using different EEG systems into MATLAB for further processing. In some other module, we will have a look at the basic steps of signal processing. What are the pre-processing step, filtering, and further steps related to event-related potential. The objective behind this demonstration is to give you an idea or provide you a platform using which you can get actively involved and try to solve or try to process EEG related data analysis by your own. If you have any questions related to this entire module, feel free to ask us in the forum. I wish all of you would have understood a bit, and it will help you for further EEG related signal processing, which will be taught in the subsequent lectures. Till then, all of you, please take care, stay safe, bye bye.